Hi everyone, we're starting a new chapter, and this chapter is on amines, which we have talked about in the past, so some of this will be review. But on this slide, I have a few compounds that have amines in them. The first one is adrenaline, and this is responsible for your fight or flight response. So notice that we have a nitrogen on the end of this molecule here, and it's bonded to two carbon groups and then a hydrogen. So that would be our amine group. On the right-hand side, next to adrenaline, we have the structure for morphine, which is a really strong pain reliever. And notice that we have an amine in there as well. And in the bottom molecule there, nicotine, this compound is found in tobacco, and it's very addictive, but notice that there are two nitrogen groups here in that compound. All right, so amines are really found in a lot of different compounds that we see or potentially use every day. So just as some review, we have talked about different types of amines before. One common one that we've used in organic chemistry is ammonia. So that's nitrogen bonded to three hydrogens, and then the nitrogen atom has a lone pair. We've also talked about the ammonium ion. So this is nitrogen bonded to four hydrogens, which makes it positively charged. And we could also have, for instance, a nitrogen bonded to four alkyl groups. And this would be called a quaternary ammonium salt. So there would probably be some sort of negative ion balancing the charge on that ammonium ion, which would then make it a salt. So if you had, for instance, like a chloride ion or something similar there. All right, so this brings us to primary, secondary, and tertiary amines. So primary amines are bonded to one alkyl group and then two hydrogens. A secondary amine is bonded to two alkyl groups and one hydrogen. And then you can probably guess a tertiary amine has a nitrogen bonded to three alkyl groups. So we'll be referencing these different types of nitrogen bonds and groups throughout this chapter. Another term that you might hear is alkaloid. An alkaloid is an amine that's derived from a natural source. So you might hear that term as well. Okay, so let's talk about how amines typically work in reactions. So we'll talk about their reactivity. So let's say that we do have a tertiary amine. So let's draw the geometry here for this tertiary amine, and I'm going to draw a lone pair in sort of like a balloon at the top there. What shape does this tertiary amine form? Do you remember the geometrical name for that configuration? Trigonal pyramidal. So it's not quite tetrahedral because of that lone pair on the top. So instead we refer to this as trigonal pyramidal. Now there are a couple of different ways that the nitrogen lone pair could interact with other groups. So that nitrogen could act as a base and protonate itself. Oh, and actually let me stick to our geometry here. All right, so that's our quaternary ammonium, or close to our quaternary ammonium salt there. And then the other interaction that this nitrogen can have is the lone pair could attack a positively charged carbon. So for instance, if we have an R group or an alkyl group bonded to a halogen, so that's an alkyl halide, we could perform an SN2 reaction where that lone pair attacks the alkyl group and we leave electrons behind on the halogen. So then we end up with our quaternary ammonium salt. Now, in the top reaction where nitrogen is acting as a base, it's typically going to act as a weak base. So let's just make a note. All right. So let's also talk about the nomenclature for amines. How do we name amines? So there are a couple of different ways that you can name amines. Just as an example, let's say we have an ethyl group bonded to an amino group. We could call this ethylamine because it's pretty simple. We could also, let's say we have like an isopropyl group bonded to a nitrogen there. We could just call this isopropylamine. So we're essentially naming the substituent on nitrogen. So in the first example, we had ethyl. In the second one, we had isopropyl. And then we just add amine to the end. So this works pretty well for simple amines. Now there is another way that we could name, for instance, that isopropylamine molecule. So for instance, we could call this, let's see, if we number the longest carbon chain, we can see that we have an amine on the second carbon. So we would start by saying, okay, we have propane. So we have a 3-carbon chain, but I'm going to drop this E because there is an amine attached. And I'm going to put a 2 in front to indicate where the amine is located. So I have 2-propanamine. So that's why I mentioned that there are 2 different ways to name amines. You can list the substituent to the amine, or you can just add amine onto the end of your longest carbon chain name. A couple of other examples. If you have an amino group attached to cyclohexane, you could call this cyclohexanamine. Or cyclohexylamine. And then just one other one that I wanted to bring up because we have seen it before. If you have an amino group attached to benzene, this has a common name, aniline. Okay, so let's look at a couple of examples for naming molecules that contain amines. So let's look at this one where we have a ketone and an amine in the same molecule. So we might have to figure out which one gets first priority. And let's look at one that's a little more complex than the structures we saw on the last slide. So here we have some stereochemistry going on. We've got a longer carbon chain and some substituents. So how would we name that molecule? Well, let's start with the first one at the top. So I mentioned we have both a ketone and an amine in the same molecule. So which one would have higher priority, the ketone or the amine? So you might have to go back and look at your notes and find that priority list of functional groups. But in general, one thing that I usually stick to is that anything with a carbonyl group will have higher priority. So the ketone will have the highest priority. So we're going to treat the amine like a substituent. So let's just make a note. So ketone group has higher priority. So we're going to treat the amino group as a substituent. So the name here, let's see, we want to number our ketone carbon chain first. So we have, let's see, 1, 2, 3 carbons in our longest carbon chain, but we also want to make sure to number the carbons so that our substituents have the lowest number possible. So if we number it from left to right, the amino group would be on carbon 3. But we could number this from right to left, and now the amino group is on carbon 1, which would be preferred. And notice that the carbonyl group is always on carbon 2, so it doesn't really matter which way we number it for the ketone, but it does matter for the amino group. All right, so now that means, let's see, our longest carbon chain is propane, but I'm going to drop the E, and I want to indicate that we have a ketone as our main functional group. So what ending should I put on there? Well, if you have a ketone, you're going to end your name in -one, O-N-E. Now we do want to indicate where the ketone group is, so that would be on carbon 2, 2-propanone. And now we're going to list our substituents in the front. So the amino group is on carbon 1, so we would write 1-amino -2-propanone. Okay, let's look at our second molecule. So this one is a little more complex. So probably the best thing we can do is just find the longest carbon chain. And we want to make sure our substituents have the lowest numbers possible, although because we have this amino group here, we probably want to give that the lowest number possible. That would have priority over any of our alkyl groups, for instance. So I'm going to number from left to right, 1, 2, 3, 4, 5, 6, 7. Okay, so that means that our longest carbon chain would have the name heptane, but I'm going to drop the E and put amine, heptanamine. And then I want to indicate where the amine group is, so that's on carbon 3, 3-heptanamine. And now we want to list our substituents. And it looks like the substituent here is a methyl group, and that's on carbon 5, so 5-methyl, 3-heptanamine. And we also have to figure out stereochemistry. So I'm going to ask you to pause the video and try to figure out what the stereochemistry is for carbon 3 and for carbon 5. And when you come back, we'll go over it together. All right, so let's look at carbon 3. And I'll use orange for this one. So what would have highest priority out of the 3 groups surrounding carbon 3? Nitrogen. And then looking at carbon 2 and carbon 4, it's kind of hard to tell because they're both CH2 groups. So then we're going to go one step further, look at carbon 1 and carbon 5. So would carbon 1 have higher priority, or would carbon 5 have higher priority? Carbon 5, right? So that whole side of the molecule has second priority. The other side of the molecule, or the other side of carbon 3, has third priority. Luckily, hydrogen, which is also on carbon 3, is in the back, so we don't have to worry about that. So if we draw a circle from 1 to 2 to 3, is that R or S? S. It's going to the left. Okay, now let's look at carbon 5. So we've got a methyl group, carbon 4, and then carbon 6. So what would have highest priority? Carbon 4, right? Because that's bonded to a whole long chain of carbons off to the left. Carbon 6 is just bonded to one other carbon, and then that's just a methyl group, so that would get second priority. And then the methyl group would get third priority. So 1 to 2 to 3, is that R or S? R. Great. Okay, so in the front of this molecule, we're going to list, or this name for the molecule, we're going to list 3S, 5R, parentheses. So don't forget about stereochemistry. That does not go away. Okay, let's do a couple of other examples here. So let's say that we have a benzene ring, and we've got a fluorine, an amino group, and an ethyl group. And then let's do another one on the bottom here. Do a long carbon chain again with a nitrogen, and we'll leave it at that. So pause the video, see if you can figure out the names for these molecules on your own first, and then we'll go over them together. So for the top molecule, we do have that amino group attached to benzene. And remember earlier we said that that was called aniline. So that's kind of our quote-unquote parent chain. So now we just have to figure out where the other substituents are located relative to that amino group. Now, because we're using that parent name aniline, that tells us that the amino group is at position 1. And we, again, want to number the ring so that our other substituents have the lowest numbers possible. Now, if I go counterclockwise, fluorine will be at position 2, and the ethyl group will be at position 5. If I go clockwise, then the ethyl group will be at position 3, and fluorine will be at position 6. So We don't want to go clockwise here, we want to go counterclockwise. All right, so let's list our two groups here. Now we do want to alphabetize, so we have ethyl versus fluoro. Which one would come first? Ethyl, right? So that would be 5-ethyl-2-fluoroaniline. So always remember to alphabetize as well. Now let's look on the bottom here of the slide. How would we name that molecule? Well, we have a pretty long carbon chain, so maybe the first thing we should do is just number it. And it doesn't really matter which way we number it, right? Because the nitrogen group is right in the middle. So we'll just figure out how many carbons we have here. Okay, we have 7. So normally we would call that heptane, but we do have an amino group there. So I'm going to end this in amine. And I also want to indicate the location of the amine, so that's on carbon 4, no matter which way we number it, left to right or right to left. But now, how do we take into account these methyl groups up here? So remember, a long time ago, we talked about how you can write capital N methyl, so N-methyl, to indicate that a methyl group is bonded to your nitrogen. Now, in this case, we have 2 methyl groups, so we're going to want to be redundant here and write NN-dimethyl -4-heptanamine. Now, do we need to take care of our stereochemistry here? No, right? So even though I drew a wedge there for nitrogen, notice that the group on the left and the group on the right here are the same. So we don't actually have a stereocenter there, but it's totally okay to draw wedges and dashes just to show the geometry of the molecule. All right, so that's it for this video. This was probably mostly review for you, but it's always good to go back over nomenclature because it's been a while since we've talked about amines and aniline and all of that. So next time we'll talk about how to prepare amines. So that might also be a little bit of review, but we'll go over some new reactions as well. So I will see you then.